Hi, welcome back to channel Teacher Norenika. So we continue chapter 5 waves on topic 5.4 refraction waves for Physics 14 KSSM. Let's get started. Okay, what is the meaning of refraction of waves? So you can see in the picture here. So you can see the water waves form. You can see it looks like a line, parallel lines that are approaching the beach. Okay, so what is this actually? So this pattern form actually is due to refraction of sea waves. Now we want to discuss further what is the meaning of refraction of sea wave. So refraction of water wave, if we use ripple tank, we can observe the pattern form on the screen like this. There is a bright and dark fringes. We have discussed earlier how the bright and dark fringes form when we use ripple tank. In the deep region, you can see the distance between two bright fringes or dark fringes is longer compared to the shallow region. Or you can say the bright and the dark fringes actually represent the wavefronts of the waves. You still remember the meaning of wavefronts? Line joining all points which are in phase. So for the deep region, you can see the wavefront become when travel from the deep region to shallow region like this, you can see here the wavefront is further. When travel into the shallow region, it becomes closer. So what caused this situation? Because speed of water wave depends on the depth of water. So when depth decrease, the speed decrease. So when speed decrease, it will cause change in the direction of propagation. Okay, so the speed decrease, direction of propagation change. So you can see due to the change in the direction, that's the reason why the wavefront become closer in the shallow region. Okay, let's look at the definition. What is the meaning of refraction of waves? The key point here is the change in the direction. Okay, so change in the direction of propagation of waves caused by the change in the velocity of waves when waves propagate from one medium to another. If we talk about light, speed of light wave influenced by optical density of medium. But when we talk about water, it depends on depth of water. So in deep region, the speed of water or the velocity of water is higher. In shallow region, the speed of water is smaller. Okay, so there is a change in the speed. When there is a change in the speed, there will be change in the direction of waves. So when the direction change, we can say water wave experience refraction. Okay, so look at this situation, the first one. So as the wave travel from deep water region to the shallow region, so this one we call it incident wave. It incident to this point. You can see this is the black line here represent the boundary. The boundary is a line that separates between the deep and shallow region. So what you do at the point of incident, we can draw a normal line. There's a blue color here. Angle between the incident wave and normal line is angle of incidence I. So from deep to shallow, speed decrease. So when speed decrease, the wave will be refracted towards normal. Here is the region where the speed refracts or the wave refract towards normal. So you can see there's a bending in the direction of waves. So here we can show that the wave experience refraction. Okay, angle between refracted wave and normal line is angle of refraction. So this is the direction. Okay, if we discuss about when the water wave travel from shallow to deep region, okay, this is incident wave, and at point of incident we draw normal line perpendicular to the boundary. Angle here is angle I. So what happened from the shallow to the deep region? The wave will be refracted away from normal. Because speed or velocity of wave increases. So you must be able to differentiate between these two situations. Okay, so remember, in the deep water region, speed is higher. In shallow water region, speed is lower. So the change in the direction of waves is caused by change in velocity of waves. Okay, when pass through a different depth of water. So in this case, when we discuss about water wave, meaning different depth of water. Okay. Effect of refraction on characteristic of waves. So we can discuss in terms of angle, wavelength, frequency, wave speed, and direction. So let's say we discuss about when the water wave travel from deep to shallow, what happened? Angle I is larger than angle R. Okay, wavelength decrease, frequency no change, because frequency of the wave depends on frequency of the vibrator or frequency of the source. Okay, the wave speed decrease because from deep to shallow. So what happened to the wave? Refracted towards normal. Later we show you how to draw the diagram for the refraction. From shallow water region to deep water region, angle I is smaller than R. Wavelength increasing. Frequency is still unchanged. Wave speed increasing. So what happened to the wave? Refracted away from normal. Okay, let's try to draw a diagram to show refraction of plane water wave. This is a glass block placed in the water. So it will create shallow region. Okay, what we do? Incident light, incident wave towards the boundary, meaning the wave travel from deep to shallow. Let's say this is the incident wave. This line, the blue line, represent the boundary that separate deep and shallow region. So at this point, what you do? You draw a normal line. Normal line is 90 degrees to the boundary. Angle between incident wave and the normal is angle of incidence. Okay, now what else that we need to draw? Draw wavefront. Remember, wavefront and direction always 90 degrees to each other. So this whole thing, we call it incident wave. The arrow is the direction, and this blue parallel line, we call it wavefront for the incident wave. Okay, now the wave travel from deep to shallow. What happened to the speed? So when that from deep to shallow, the speed decrease. So we draw direction of refracted wave. Okay, this one is a distance between two consecutive wavefront is lambda or wavelength. Okay, let's say this is the direction of the refracted wave, bends towards normal because the speed decrease. Okay, then what we do, we just draw some of the wavefronts for the refracted wave. Okay, perpendicular to direction, but now the distance between two wavefronts becomes shorter. The wavelength decrease. So this is the initial wavelength in deep region. So when travel in shallow region, it becomes shorter. Why it becomes shorter? Because the speed decrease, frequency constant. Okay, later we can produce formula by using the formula V equals to F lambda. Okay, so this whole thing we call it refracted wave. Okay, so what else we can see from here? The angle between normal and incident, we call it angle of incidence. The angle between normal and refracted wave is angle of refraction. So you can see here, when travel from deep to shallow, you can see the angle R is smaller than I. Okay. Okay, this one, look at one example. Let's say water wave travel, okay, from deep to shallow. So what happened to the wave? You can draw normal line here. Normal line is 90 degrees. 90 degrees to the boundary. This is the boundary, this line. Okay. So what happened to the wave? The wave will be refracted towards normal. So you can see when you draw the wavefront, lambda or the wavelength for the shallow is shorter than the wavelength in the deep water. Okay, so this is the Ripple tank that you might use in your lab. So it will produce image form on the screen. Okay, so to create the shallow region, we can put many shape of the perspex or glass block to create the shallow region. It can be in trapeze shape, it can be a concave or convex shape, okay, or just a rectangle shape. Okay, so this one will produce a different pattern of the refracted wave on the screen. Okay, let's say we have a different pattern of the perspex or plate that placed in the water to create shallow region. For this one, the shape is rectangular. Okay, so when wave travel from deep to shallow and then to deep, you can see, okay, on the shallow region, so we still produce a straight and parallel wavefront. Okay, so you can see the wave direction is incident along the normal line, so there will be no refraction, but the speed decrease. That's the reason why the wavelength is shorter. Okay, when you put a trapezium shaped plate, okay, so this is incident wave. So at this point we draw normal line. Okay, so from deep to shallow, refract towards normal. So when reach this point, again you repeat the same thing, draw normal line. Okay, and then from shallow to deep, bends away because the speed increase. Okay, so here the bends away, so you draw the wavefront 90 degrees to direction. So if you follow the step carefully, you will get a correct pattern of wave for the many shape of plate put on it in the water. Okay, so let's say we put a convex shaped plate. Okay, you want to put it, because of the shape, what happened to the water wave, it will converge to one point. There is a focal point of the convex shape. So what happened to the wave? Okay, the shape of the wave become circular, more curve, become curve because of the shape of the convex shape. Okay, so this is the pattern form. On the shallow region, the distance between two wavefront becomes shorter. Okay, and this one is for the concave shape. What happened to the wave when pass through? It will diverge. So this one also produce curve shape of the refracted wave. And this one is the triangle. So same thing, we just repeat the same thing. We draw a normal line. If the from deep to shallow bends towards normal, and then we draw the wavefront. Wavefront in shallow region is shorter, and then when we go to the deep region, it will bend away from normal. So we draw the wavefront. So what happened? The wavelength increases again. So you must understand the concept of refraction. What factor that affects speed? Okay, if you discuss about water wave, we just discuss about depth of water. Okay, if there is change in depth, then only there is change in speed of water wave. Okay, let's try to produce a formula so that we can answer calculation problem later. So this one, deep water. So we can mark a distance between two consecutive wavefront. We put as lambda 1, and then the speed of water in deep region is v1. So in shallow water, the wavelength is lambda 2, and the speed is v2. So from the formula v equals to f lambda, we know that frequency is constant because the wave coming from the same source, from the same vibrator. So when f is constant, we can say v divided by f is equals to constant. Or we can say v1 over v2 equals to f lambda 1 divided by f lambda 2. So you can cancel the f because same value of f. So what we get, v1 over v2 equals lambda 1 divided by lambda 2. So this relationship can be used to solve problems involving refraction of waves. Okay, let's look at one example, a calculation. Figure 5.43 shows propagation of water wave from region P to region Q of different depth. Speed of water is 18 cm per second in region P. Determine speed of wave in region Q. So you must understand the concept of wavelength. Okay, the blue line here represent wavefront. Distance between two wavefronts, two consecutive wavefront is lambda. So here given between two we count as 1 lambda. So how many lambda here? 1, 2, 3, 4. So 4 lambda. So how to find lambda for the deep region? So use the formula. So lambda 1 equals to 12 divided by 4. So you get 3 cm. Because each of these lambda is 3. 3, 3, 3, 3. Yeah? This one for deep region P. And then for region Q, we do the same thing. We just count how many lambda. 1, 2, 3, 4, 5, 6, 7, 8. Meaning 8 lambda equals to 12. Then lambda 2 equals to 1.5 centimeter. And then we can have the values here. Given V1 is 18. Thus we want to find V2. So we apply the formula that we discussed before. Okay, that we discussed before this one. So V1 over lambda 1 equals to V2 over lambda 2. So you just substitute all the values in. So you can get V2 is 9 centimeter per second. So the unit depends on the unit given here. If given in meter per second, so your answer will be meter per second. Okay. Okay, now when we talk about the water wave, we discuss about the depth of water. Okay, when there is change in depth, there will be change in speed. So when there is change in speed, the wave will be refracted. Okay, so what happened to the sound wave? Does it also experience refraction? So this one, there's a question here. Why sound is heard louder at night as compared to daytime? Okay, so this is the daytime and this is the nighttime. So we can discuss what exactly happened during nighttime and daytime. Let's discuss the first one. During the day, what happened to air? Air that is closer to the surface of Earth is hotter than the above. Okay, above is hotter than the bottom part. Okay, sound move faster in hot. During the day, air that is closer to the surface of the Earth is hotter. Okay, at the bottom is hotter than the above part. Sound move faster in hot air because the molecules of air move faster. So it will transfer the energy or sound wave faster. Okay, so in hot air, the speed of sound is higher compared to the cold air. As such, sound is refracted away from the ground. Thus, observer cannot hear sound clearly during daytime. So you can see the air now divided to a few layers of air. Near to the ground is hotter, above is colder. So when travel from hot to cold, what happened to the speed? The speed decrease. Okay. So when we draw normal line here, from hot to cold, what happened to the wave? It will be refracted away from the ground. Refract towards normal, but refract away from the ground. So what happened to the sound? Sound will leave the ground and then move to atmosphere. Okay, so it will just lost. Okay, thus observer cannot hear sound clearly during daytime. So during nighttime, what happened? Okay, during nighttime, air that is closer to the surface is colder. To the surface is cold, above is hot. So sound refracted towards the ground. Okay, so when refracted towards the ground, this caused the observer to hear sound more clearly during the night. The sound that transferred, it returns back to the ground due to the refract towards the ground. So at night, the sound is heard clearly compared to daytime. Okay, and another situation is why the wavefront or water wave follow the shape of shoreline and propagate to the beach. So you can see this is the beach. You can look at here the shape here. This is the cape part and the bay cape. Okay, so the water wave coming from the middle of the sea. So what happened to the wave? So when we talk about the cape and bay, the cape is shallow water region while bay is deep water region. Okay, So cape is shallow, bay is deep. Away from the shoreline, the wavefront of water is almost straight and parallel because water wave move at uniform speed. Okay, middle of the sea, the depth is quite uniform, so we can say the wavefront is almost straight and parallel, and you can say uniform speed. But when the wavefront of water propagates to the cape, the speed of water wave decreases, causing the wavelength to be shorter. Wavefront of the water approaching the bay move at higher speed, and the wavelength is longer. This causes energy to converge towards the cape. So you can see here, energy converts towards the cape but diverge when approaching the bay. Okay, so water wave energy diverges from the bay and spread out to wider region. So here diverge, here converge. So what happened to the energy if converge? Of course, the amount of energy here is higher compared to this part. Okay, so what happened to the wave? As we know that energy is related to the amplitude of wave. High energy means strong wave, so the amplitude is higher. So as you can see from here, when the water wave converge, it will produce wavy area. Bay is calmer because the amplitude is smaller. Okay, so what happened next? Water wave energy diverged from the bay and spread out to wider region. Thus, amplitude of wave at bay is smaller than the cape. That's the reason why the resort or the safer place for the swimming activity normally is bay area, not the cape area. Even the resort also built near to the bay area, because this one you can see the water is calmer compared to the cape part. Okay, I think that's all for this topic, refraction. You can search for more video on this and do more reading on the refraction to understand better. That's all. Thank you.